Okay, for the next example, for this particular problem, so I have 4 sine x cos x is equal square root of 3. So we're going to use the same trick as before. So whatever constants that is not related, so I'm going to move it to the right hand side of the equation. So I'm going to rewrite this equation as sine x cos x is going to equal square root 3 over 4. So that's going to be my equation. But the problem is that I have quite a problem here. So the thing is that we have quite a problem over here. So because I have two trigonometric functions, so which are product of each other. So I have sine x, which is being multiplied by cos x. And when we have these two functions together, so there is no way that I can actually find what is going to be the value of x, because when we wanted to solve, there should be only one trigonometric function. So when you come across something like this, for which that you have a very complicated form, or you have like a product of two different trigonometric functions, so what you have to do is, so you have to find a certain trigonometric function that can simplify your trigonometric expression. So if you come across in workbook in chapter 4, so we have actually come across this form for which I have sine, which is multiplied by cos. So don't worry, later when I have time, so I will compile all the trigonometric function that we have come across. And I'm going to put it together so that when you do your exercise later, so you know where to refer to it. I'll put everything simply in one PDF file. Okay, so basically I was referring to this one. So this is actually the trigonometric property that we're going to use, because we have a sine x, so which is being multiplied by cos of x, which is similar to the form that we have over here. So let's paste it so that we can see this clearer. Let's put this side to side, in fact. Okay, so when I put this side to side, so I can see that how similar they are. So the fact that we have on this side sine x cos x, and I can actually rearrange them. I can write that, so sine x cos of x is basically equivalent to sine of 2x divided by 2. So this is going to be the property that I'm going to substitute in this equation right here. I'm going to write that. So according to what we have seen, so this, so I'm clear this first. So this sine x cos x, so can actually be replaced by sine 2x over 2 by using this particular property right here. And that is going to equal square root 3 over 4. So now see what happened is that, so instead of like having sine being multiplied by cos, I only have one trigonometric function, so which is going to be sine 2x. So that is good news. But now I'm going to get rid of the constant over 2 at the bottom. So I'm going to write that, so sine 2x is actually going to equal square root 3 over 2. So how do I get square root 3 over 2? Because I bring this to the other side. So I'm going to have square root 3 over 4 multiplied by 2. So that is going to equal square root 3 over 2. So now that I have in this form, so I'm going to use the same way to solve for this, using the way that we have seen in the previous example. So I'm going to have 2x is going to equal sine inverse of square root 3 over 2. And using my calculator, I'll be able to figure out that. So sine inverse of square root 3, so divide by 2 is going to give us, sorry, it should be sine inverse, not sine. Square root 3 over 2. So that is going to give us an angle of 60 degrees. Okay, but then again, so using the cast rule, so this should be where the quadrants are going to give you positive sign values, which is going to be on the first quadrant and also in the second quadrant. Right, so but the thing is that here, this is not going to be x, but this is actually 2x on the right hand side. Alright, so what you have to do is going to be something like this. So how do you deal with that? So now I'm going to list all my angle. So my 2x angle is going to be on the first quadrant, so which is going to be 60 degrees. So on the second quadrant, so that is going to be 180 minus 60. So I'm going to have 120 degrees. And when I wanted to know what is going to be x, all I have to do is divide this by 2. So my x value is 60 divided by 2, that will be 30 degrees. 120 divided by 2, so that is going to be 60 degree. So but the thing is that we have a limitation that states that our x value, it should be a value between 360 and also a 0 to 360 degree. So previously we stopped our rotation because it's already close to 360. Because if I were to make another rotation, I know that it would have exceeded 360. But for this case, when I make one full rotation, so it stopped at only until 120. So what happened is that I'm going to make another rotation and see whether or not it exceeds 360. So how do I make another rotation? So it's simply going to be, we know that one full rotation is going to be 360. So plus this value over here, so that is going to be 60 degree. So I'm going to have 420 degree. And when I divide that by 2, so that is still going to be 210, which still doesn't exceed 360. So therefore, another angle is going to be 210 degree. And then I'm going to add another angle over here, because it could also be, so 330 degree plus the one in the second quadrant, so which is going to be 120. So when I add them up, I will get 480 degree. So divide this by 2, so I will end up with 240 degree. So that is going to be the outcome. Okay, so should I proceed to another rotation? So if I were to proceed to another rotation, so it would have been 720, so plus 60 degree, because when we have two full rotation, that would be 360 multiplied by 2, which is 720. But actually, so if I have 720 plus 80, so that is going to be 780 degree. And if I were to divide that by 2, so this is going to be 390 degree. So that would have exceeded the 360 degrees. So therefore, I shouldn't have take another rotation. So I should have only stopped at the second rotation. So therefore, so our answer is going to be just until here. So our x is going to take 4 angles, 30, 60, 210, and also 240 degree. But if it doesn't exceed, then you have to keep making rotation until it actually exceeds. So that is the rule. Okay, so that is going to be for C. So now let's have a look at D, the last one. For the case of D, so it's going to be very similar to C, so you have to use a certain rule. So I have 2 cos of x over 2, so plus 1, and that is going to equal 0. First, let's rearrange this. So I'm going to write the fact that cos of x over 2, so that is going to equal negative 1 over 2. Or my x over 2, so that is going to equal cos inverse of 1 over 2, and according to the calculator, so cos inverse of 1 over 2 or 0.5, so that is going to be 60 degree. And this is going to occur in which quadrant? So we have to be mindful, because this is where the cos should be negative values. So it will be in the second quadrant and also in the third quadrant. So those are going to be the places so where cos are going to be negative. Okay, so x over 2 is going to equal 60 degree. So x over 2 first is going to be on the second quadrant. So that is going to be 180 degree, so minus 60 degree. So that is going to be my value of the angle in the second quadrant. And in the third quadrant is going to be 180 plus 60 degree. So we don't know like whether or not we have to do another rotation, but let's have a look first. So whether or not this already met our what do you call that, restriction from 0 to 360. But the thing is, now we don't want x over 2. So what we wanted is going to be x. So how do we get x? So we have to multiply each of this angle by 2. So 180 minus 60. So that is going to give us 120. And this is going to give us 240 degree. So when I multiply by 2, this is going to be 240 degree. So when I multiply this by 2, this is going to give us a value of 480 degree. But remember, so we have a restriction that our value of x should be only between 0 and 360 degrees. So therefore, this is not going to be our solution. So our only solution is going to be 240 degree because of the restriction. So that is going to be our only value of x. Okay, so basically the idea is the calculation is going to be pretty much the same, but you have to be very careful about the restriction. And then now I'm going to show you the last question, so which is example number 2 over here. So let's copy this question instead, because this is kind of long for me to write. I'm going to paste it right here. So this is going to be our equation. So this is going to be quite a challenge. The reason is that first, because if you have a look at this question over here, so we know that we have cos multiplied by cos, sine multiplied by sine. So in order to shrink that to a simpler equation, I have to use a certain property. So that is going to be the first reason why this is going to be slightly complicated. The second reason is going to be because of the angle. So that is actually a wide angle, so which covers from 0 until 720. So basically that is twice the rotation, because it covers from 360 multiplied by 2, which is 720. Okay, first of all, what I'm going to do is, I am interested the fact that we have a constant 2 at the front of both of this. So I'm going to do is, I'm going to factor them out, because I don't want them in the equation. So I'm going to have 2. So here I'm going to have cos of, let's put this as x over 2 cos x. And then minus, here I'm going to have sine of x over 2 sine x. And that is going to equal 1. Again, let me rearrange this. I'm going to put 2 to the other side. So I'll end up with cos of x over 2 cos x minus sine of x over 2 sine x. So this is going to equal half 1 over 2. Okay, this is going to be the same problem as we have seen in example C, for which instead of like having one function to solve, one trigonometric function, I have a product of cos and cos over here. So minus sine multiplied by sine. So how do I actually simplify this? Which is a very complicated function. First, I have to shrink it down, make it simpler. So there is going to be a certain property that I can actually use that would suit this problem right here. So bear in mind, we're looking for something with cos multiplied by cos minus sine multiplied by sine. So we have already come across this before, and that would be in 6.1. So if you notice, it is very similar to what we have over here. So I have cos x cos y minus sine x sine y, and that is actually equal cos of x plus y. So let me put it right underneath so we can actually compare them. Okay, so this is actually the same. Okay, so what is going to be my x according to the formula? So this is going to be x and this is going to be y. So I have cos x cos y. Again, this is going to be sine x and this is going to be y. So therefore, when I change this according to the formula, so my cos x over 2 cos x minus sine x over 2 sine x is actually equivalent to this. So therefore, this is going to transform to cos of x. What is x? X is going to be x over 2. And what is going to be y? So y is going to be x, and that is going to equal 1 over 2. And if you notice inside here, so I can actually easily perform this operation and simplify them. I can actually write this as cos 1 over 2x plus 1, that is a half plus 1. So that is going to be 3 over 2x, and that is going to equal 1 over 2. So now, like we previously started with a very complicated equation by using the property and by doing the operation inside here. So we actually come across something that we can easily solve, right? So here what I'm going to do next is I'm going to rearrange this, and I'm going to find what is going to be 3 over 2x. I'm going to write that 3 over 2x is going to equal cos inverse of 1 over 2. So we have seen just now the fact that cos inverse 1 over 2 is actually going to equal 60 degree. Okay, so now let's have a look at the cast rule. So where is this going to be positioned? So this should be somewhere where cost gives you a positive value. So where does cost gives you a positive value? So that would have been at the first quadrant and also the fourth quadrant. So therefore I'll be able to get that. So actually, okay, let's figure this out first. Let's write this first. So 3 over 2x. So the first quadrant, it would have been 60 degree. So in the fourth quadrant, so this is where you can have 360 minus the reference angle. So therefore, this is going to be 300 degree. But the thing is that the answer, what we wanted is not 3 over 2x. So what we wanted is going to be x. So what you have to do is, so I have to multiply so each of the angle by 2 over 3. So now let's have a look. What do I get when I have x? 60 being multiplied by 2 over 3. So 16 multiplied by 2 over 3. So that is going to equal a 40 degree. So that is going to be our first angle. So now 300 being multiplied by 2 over 3. So that is going to give us 200 degree. But this is not going to stop until here. So the reason is that we have a very big restriction, because our x value is actually going to be a value which is between 0 and also 720 degree. So those are going to be the value. So we have to proceed and take all the x that is between 0 and also 720. We're not even close. We're not even half to the value of 720. So the next value, so I'm going to make another 10. So it's going to be at 360 plus 60. So that is going to be at 420 degree. So 420 degree, so multiplied by 2, so divide by 3. Okay, so that is going to give me an angle of 280 degree. So that is going to be our angle. And another rotation, so that is going to be 360 plus the second angle, so that is going to be 300. So that is going to give us a value of 660 degree. So 660, so multiplied by 2 divided by 3, so that is going to be 440 degree. So now we already have like our first revolution. Okay, so we already have a full circle in our quadrant. So that is why, so this is actually going to be our second rotation. But do we actually have to proceed, or do we actually stop over here? But the thing is that if I were to have a look, so the last angle is still far away from the 720. So that is why we have to make another rotation. So the first rotation, we add 360. For the second rotation, we add 360 to the value that we get. So therefore, for the next rotation, for the third rotation, so we have to add 720. So I'm going to have 720 plus 60. That is going to be 780 degree. And 720 plus 300. So that is going to be 1020. So now I'm going to have a look if they are still in our restriction. So 780 multiplied by 2 divided by 3. So that is going to be 520 degree. 1020 multiplied by 2 divided by 3. So that is going to be a value of 680 degrees. So yes, so they are still within our limitation. Okay, now I already have like 3 rotation. Do I actually have to proceed? So the answer is no, because if we were to proceed, what happened is that, so we're going to have 360 multiplied by 3. So that is going to be 1080 plus our first angle, so which is 60 degree. So that is going to be, what value is that? 1140. And when I multiplied this by 2, divide this by 3, I got a value of 760 degree, so which has already exceeded 720. So therefore we don't have to proceed anymore. So this is where we are going to stop. Right, so usually the problem arises only when you have coefficient like this. So when you have 3 over 2x, x over 2, then you have to be very careful. You have to know very well, so how many times that we have to rotate the quadrant. Okay, So when you rotate for the second time, you add 360 to the reference angle. When you rotate for the third time, you add 720 to the reference angle, and so on. So every single time you keep adding 360, so until you actually fulfill the restriction. And of course, you can always check the value. So you can substitute this x value into the original equation given, so which is over here, and find whether or not they actually give you a value of 1. So when you have substitute all this value of x. Okay, so basically, so this is not very hard as long as you actually understand the concept of CAS, you know how to use your calculator, so you should be able to solve this equation.